Hi there and welcome to this first video for Senior Physics on motion. In this video we're going to be looking at scalars, vectors and the terms which are associated with the motion that we'll be looking at. Okay, so let's first explain the difference and define the differences between scalars and vectors. So any quantity that we have will have two types of values. Those two types of values will be a scalar value or a vector value. So what we want to do is to describe what each of these values happen to be. Now, a scalar quantity is basically any quantity which basically just gives a magnitude or a size. For example, if I was to say that apple weighs 300 grams, that is a magnitude. It doesn't tell me anymore. 300 grams is all it is, and as a result, that's all the information that I need. Now, when we come to a vector, what a vector does is it includes the idea of magnitude and size, but also includes the idea of direction. For example, a car was traveling at 3 meters per second. Now 3 meters per second gives me the speed, but it doesn't give me really where the car was going. Now if I then said the car was traveling at 3 meters per second down the road, I've got a direction. Or the car was traveling at 3 meters per second in a westerly direction. I've now got more information which allows me to explain where that car is going. As a result, these vectors allow us to say where a certain variable is being applied, and it allows us to join vectors together so that we can get an overall. And so we have to understand what is a vector quantity, because often if we're then asked to find that quantity, the result is that you have to do two calculations. The two calculations being calculating the magnitude as well as calculating the direction. A lot of students find that difficult and forget the idea of putting in direction. Now this will become more apparent as we move through the course, so bear that in mind. Scalar only gives us a magnitude, so if it's a word which basically describes a scalar quantity, all you have to do is calculate the size. However, if you are asked to calculate something of that's a variable which is a vector quantity, you must calculate the size and the direction, because that is important. Okay, so what quantities, what variables do we have which are scalar and vector? Well, our scalar quantities are going to be things like distance, speed, acceleration, force, and energy. All of these can just be used as a size. For a vector quantity, instead of distance, we have displacement. Instead of speed, we have velocity. Acceleration and also force can be vector quantities. So you'll notice that acceleration and force can sit in both. So we can have acceleration just as a size, or we can have acceleration as a size and a direction. Likewise with a force. Force can be just a scalar quantity, basically a size, and a force can also have a vector quantity where it's also got a direction linked on it. For example, when you're pushing a mower, you'll exert a force, but it will be at an angle. That direction is very, very important. You pick up a heavy cricket bag or hockey bag between two people, the force acting on the handles is very, very important. You try and lift the hockey bag up, straight up, then the result is you're going to actually increase the amount of force that you've got to put in to lift it up. Get two handles at an angle, the result is you decrease it. So those are the sorts of things that we'll be looking at when we start working with these ideas of vectors. So now what I'd like to do is to basically run through some of the terms, definitions, units and symbols that we use for some of the motion unit terms that we're going to be looking at. So here's an example of the various motion terms that we're going to have. We've got displacement, distance, speed, velocity and acceleration. Those are going to deal with all our motion units. Now you can see they've got specific symbols. Those symbols basically are the symbols that you would see in a lot of the algorithms or equations that we're going to be using. The key thing I need people to understand is their definitions. By understanding the definition, then the result is that we can apply that to our calculations and our problem solving. Now distance is given the symbol d and is measured in units of meters. The definition is basically how far it moves. However, displacement is going to be a vector. It's given the symbol s. It has a unit, again, of meters, but it's also going to incorporate not how far an object moves, but also its direction. Speed is given the symbol v or u. U often is the initial speed, v is the final speed. In some countries you'll see v have a little subscript, vi or vf. V with a subscript I is the initial velocity, v subscript f is the final speed. Sorry, we're working on speed at the moment. It's measured in meters per second, which is ms to the negative 1 or m/s. Any notation will be accepted. Now the speed is literally how fast an object moves. Velocity has the same symbols and the same units, but again there's an idea of direction. Now acceleration basically is given the symbol a. Its units are meters per second squared, ms to the negative 2 or m/s/s. Now just to talk about that notation for a quick second, anything to the power of a negative is 1 over, it's an inverse. So hence you can see that ms to the negative 2 means that we've got two time components which are put together. Sometimes it can be written as m/s squared or m/s/s or ms to the negative 2. You need any one of those notations will work, but you need to make sure that you can identify them. The definition for acceleration is how much an object's speed changes over time, plus its direction if we're talking about it with respect to a vector. So you can see there that we've got a variety of different definitions which are going to be basically stating whether it's a scalar or a vector quantity. Okay, well I hope you found that useful. Thanks for watching, and I look forward to you joining me again.